So welcome to the show, George. This is a showcasing AI for business. But what you've got today to show and to talk about is complete data sovereignty, because you are running your own local large language models off your own hardware, not sending your personal data to frontier model providers like OpenAI and Google and such. So I really wanted to touch on what you've built, how you've done it, and how you're keeping your data safe. Do you want to introduce yourself?
Yeah, thanks, Mike. Yes, it's been a journey, certainly. Securing your own data. I mean, we've all been there. We've all been there with trying to get jobs done and trying to get our work done. And at some point, you've got to cross the road of I've got to hand over either an API key, or I've got to set up an ENV file with a reference to it, or I'm going to have to secure that in some way into to not put that out into the ether. Into the large language model itself, so it can then re-reference that
I think
accidentally.
I think where most people come across this first and foremost is they've got something like Claude or ChatGPT, and then all of a sudden it's got a little connector underneath it that says, "Do you want to connect to your Google emails or your G
Yes,
Drive?" And on the face of it, it's like, yeah, I definitely want to do that, because now I can ask Claude or ChatGPT or whatever to go search my files and do things for me. But the problem is, our entire life lives inside of our emails and our G Drive. So do you really want
that's
to give it that kind of connection? And then you can give it
that's it.
connection to just read only. You can give it connection to be able to read and write and create files. At first, you want to make it read only, but even just making it read only is something that you might not want to do. So, what are the options here?
Well, yeah, that's it. There's lots of ways of doing it. As far as you can create the tools to use the tools to access that data rather than allowing the model itself to it. But you're right. We're giving the models a lot of access to a lot of data because it's convenient. Essentially, it's convenient for us, and it gets the job done. And sometimes it's a it's it's a necessary step, but in that respect, it really isn't. At the same time, we've got the ability. These tools are here, and they're very useful. They're very useful at building the frameworks to be able to give access to the models that you want access without ever actually leaving your network. Um, the, the the
Explain
real
that,
question is,
because that's the
yes,
crux of it, isn't it?
that's the well, that's the real question. Is well, what is it that you don't want to share realistically? And that's one of the questions. That's really what brought me to the local model doorstep, as far as what don't I want to share? What am I happy to share? What's convenient? What do they cover? I mean, a lot of these, a lot of the subscription models will guarantee your privacy to some respect, or at least offer to reimburse you if you were to be put out in any way. Um, but at the same time, you've got to ask: does that data actually even want to leave my network? Does it need to? Do they need to have access to that information?
Mm.
Um, for me, one of the things was being able to talk to my AI through text to speech, speech to text. I felt quite uneasy having your Alexa or whatever it might be listening all the time, listening out for that key word,
Hmm.
especially when you don't really have sorry, you really don't have ownership of that once it leaves. Once it leaves your network, it's on there, and that's really a trust of, do I trust them to to look after that and not leak it, or not be not really um, allow others access to the data you don't want them to. So, do I want my Alexa listening into all of my family's conversations all the time? And I know, obviously, it doesn't get stored, or they say it doesn't get stored, but it is an avenue that could be accessed if it's got a connection to the outside. Then it could be used. It could be used as an attack vector in some way. It could be used in a lot of ways that perhaps you don't feel comfortable with.
Yeah, I
That
never
might
personally bought Alexa for that reason alone, but
No.
and I've turned off the Siri and everything. But then there is convenience, isn't it? Because my wife is using it, so it's probably hearing me
This
anyway.
is it.
But I think we know the reasons why we feel uneasy about it. But I know that you've got some solutions, which a lot of people probably haven't heard of, which involves downloading your own models and installing them on a home server that you've got and running it inside of your own network, which I thought was like awesome.
Yeah, well, it's really not out of reach for a lot of people. It seems like these things should be quite difficult or intricate or involve a lot of layers, and in some regards it can do, but in its simplest form, it's really not that bad to harness and to apply in your day to day. I've mentioned the text to speech and speech to text that we often use through the Alexas and the questions that we ask it and such. That certainly for home automation and that regard, local models have a huge place in being able to secure your data locally, make sure it never leaves your network, and that you have access to it when you want, rather than relying on a cloud model. Especially a lot of it's just taking ownership of the data itself and how, and do we say your footprint, your digital footprint, as it were. You don't necessarily need to share that with a cloud or to send it anywhere beyond your network when you can run it as simply on an old laptop, say. We're not talking a high spec laptop. We're talking something around a late 2010 model IdeaPad or something like that. The one that you have in the cupboard could be repurposed to act as a local first inference model before you even need to step outside.
So
don't get me wrong.
Let's unpack that a little bit, because I want to get to the how, because I have done something. I mean, you've done more than I have with this, but I have downloaded local models onto my mobile phone, so I can run local models off my phone if I don't have internet connection. So if I'm on a plane and I still want to be able to use AI to ask questions and things like that, I've got a model here I've got a couple of models that I've downloaded that I can use. So that just proves the concept that you can actually run some of these models off as long as you've got enough RAM. So my phone is a Samsung Fold and I've got 16 gigs of RAM in this, no, 12 gigs. But the models I'm running only use 3. They're only 3 gig models. So it means that I've got enough bandwidth in the RAM left to be able to load up and run a model and ask it a question. It's the same premise, I guess, on your home PC that you're running, but you've probably got some bigger, more advanced models. So what I'd like to get into is, what models have you run? How have you installed them? What can they do? What's the difference between a larger model versus a smaller model? What's the difference between a model that I can run on my phone versus a bigger model that would need a proper graphics card to run, and that kind of thing?
Absolutely, and that is a bit of a minefield in that respect. There are so many models now, cut and shaped to so many purposes. On your phone, I'd imagine you're running something between a sort of 1 to 3 billion parameter model thereabouts, and
that's right.
And they are great for general questions and general information. Whether or not I trust a lot of what it says is questionable. What you have to understand is that these models are built on huge data sets, and you can isolate certain areas of that, which is where you end up with specialized models, say that are trained in specific fields or specific tasks or whatever it might be, that can perform almost as well. I'd never go out there and say as well, but almost as well as your paid frontier models. And sometimes that's good enough. Especially when it comes.
There's a potential that they could perform better, because as far as I understand it, your frontier big model like Fable has been trained on loads of different parameters, loads of different topics, essentially, because you can ask it almost anything and it'll be able to answer on almost anything. But if you just need a medical model, you don't need everything about car maintenance and poetry and stuff like that. So you just it's just the aspect of the model that's been trained on medical, and then you can fine tune it, and you can for medical stuff, and you can what's the word, begins with an A. I forgot the I forgot the word. It's on the tip of my tongue. So you've got quantizing, you've got the parameters of the model, you've got the adjustment.
Yeah, that's right. You've got the fine tunes, you've got adapters that you can apply
that's
to
the
model.
word. That's the word I was looking for.
Yes.
Yeah.
Yeah.
And therefore you might be able to make it even more precise to a very specific topic, even though it's a smaller model. Is kind of my point.
100%, and there are cases, outline cases, where a local model will 100% outperform a frontier model, only because that's purely what it was designed for, and that's, as you say, that's all it knows. If that's all it knows, it's harder to step outside of what it knows when, that's really not something that it can consider.
So that's a good point. So there's potentially less variance in the response, so it can be a little bit more deterministic because it only knows, like this model, for example, only knows about medical stuff, so it's not going to
confuse itself with other fields of similar. Exactly.
And it's a smaller model. It's probably cheaper to run. It's definitely going to be cheaper to process. You can run it locally on less powerful hardware because it's got less parameters. It's a smaller model. So there's a lot of benefits to it.
Absolutely. When you can narrow down the scope and the task itself, I mean, Home Assistant's a good example of this, that we're all running. It has a limited set of tools that it can call. It has a limited set of tasks that it needs to perform. And the repetition rate is very high, where, you're generally asking it for the same thing over and over. That's an ideal candidate for a local model where it has a narrow scope, it has a small tool set or set of tool sets, narrow scope of skills, and it's if you were to put then a model behind that that was specifically trained, which there are out there on the tools that it's going to use, and one of them being the Home Assistant framework, then it makes much fewer mistakes. It works much quicker, and it will run on minimal hardware. And that's kind of the thing, because you can run these models on pretty much anything, as you say, as long as it's got the resources to cover it. Where it comes down to is usability. I mean, there are examples now of people running frontier models, hundreds and billions of parameters, or trillions of parameters now, that you can actually run, like you said, on a mobile phone or on a very low-end computer. The result of that really is that you're just not going to get a lot of tokens per second. I mean, we're talking, it might even take up to 10 seconds to get a token, but you are going to get the performance of that frontier model just at a very, very slow rate.
So for the less technical people, that basically means that the output is slower, so you're going to have to wait a bit longer. But it is possible to run them. You're just going to have to wait longer. But the advantage, of course, is if you run it on your own system, you're not sending that information over to a cloud provider that's going to process that information on their servers and then send it back.
Exactly. And sometimes you don't need an instant response. Sometimes it's something that could be considered or left to run overnight, where you need the inference of a large model, but you only have the hardware to run a small model. And again, these are outliner situations. 90% of my communication or my data flow goes through subscription models because they are fast, they are instant, and they're very good, and it's worked. The framework is there for you to immediately be able to reap the benefits. Where local models really come into shine is what, as I say, when the task is narrow and specific, and you don't need to have an all-knowing, all-seeing. In fact, as you mentioned before, sometimes knowing too much can be detrimental to the
Yeah.
to the output. And that can be seen in anything from customer service agents, where you don't want to going off on a tangent about some random thing. It needs to stay on point. It needs to stay, within the the, the response sets that you want for your agent to reply with.
I want to get to how to install them. That'd be a good thing to cover.
Yes, I mean, well, that's how to install and run your own models. You mean for recreational, for personal use, or for business use?
I was surprised at actually how easy it is. You've already mentioned earlier that it's actually pretty easy, but it is, isn't it? I mean, on the phone, so there's an app called Ollama, and it's available on desktop, on Mac, on PC, and on Android. I've got an Android phone, and you install that, and then it's basically a user interface into different models that you can download, and then you just download that file. Basically, it lives on the hard drive of your device, and that's what then loads up, and you run it, and then it works just like you would expect ChatGPT or any other cloud-based one that you've used previously. It's just that it's running on your own hardware, and it's running. You can run offline, and it's not sending that information to the cloud. It's running and processing on your system. So I've used Ollama for that, and you pointed me to Hugging Face, where there's a world of different models to download and different types, and that's a community of developers who have putting up their own models or retraining foundational models with adapters, which is a word I was looking for before, and reducing them down, quantizing them, and things like that. So that's how I've done it. Have you got any other tips on how to get going with loading up and installing and testing local language models?
Yes, absolutely. I mean, it's a case of there are many ways to run it. If you were on Windows, for example, there's Docker. You could run a Docker container, and that will containerize the model and keep it isolated, say off your actual system, and create a virtual system for itself to operate within.
That's a good idea.
And then obviously there's lots of layers to running your own local LLM. I mean, running the model itself, excellent. You've got access to essentially what is a very good model. Depending on which one you pick, it'll be good at the tasks that it set out, whether it's a coding model, whether it's a general assistant model, whether it's, as you mentioned, a medical-based model, or whatever it's been trained on for its data sets. That's how it's going to respond or going to answer your queries. What really gets interesting is when you try and create an agentic flow from that, which requires more than just talking to the model itself. It's you then really have to put in a thought process for it of how it's going to solve the problems that you presented it with, and how it's going to work its way through that. And again, the skills it's going to use that you make available to it, the tools that it knows how to reference, which can be different from model to model, and year to year, from where they're brought out. It's very much an ever evolving workspace where there is really no right answers, and if they are right, they tend to only really be right for a short space of time until.
For sure, rapidly evolving. But if I wanted, so let's say that I've downloaded this local language model. I've done it two ways. I've also done it through Claude Cowork as well, and it installed Whisper. We're back. We're back. George's camera fell down. But so the question I was asking there was, you've installed a local language model, but you're saying about making it agentic, and so one thing that I've installed on my system is Whisper, which I think is an open source model natural language to text that can transcribe audio
Yes.
from OpenAI, and because it's installed on my system and I'm using Claude Cowork and it knows that I've got that, if I give it an audio file, it now can then use that process, that application to transcribe my audio, which is great. So I don't have to pay for an app that's going to charge me. Some of them out there, will charge for that service. But if I wanted to, instead of using Claude Cowork, if I wanted to use one of my local models that I'm running through Ollama that I've got installed on my system, how can I get that local model to understand that I've got tools and skills and things to make use of?
Yeah, it's a good question, and again, there's many ways to achieve what you want to achieve, and there's many people looking at it from different perspectives. Just to throw a few examples, I mean, what we're referencing at the moment are harnesses essentially, and what a harness will do is well, within the name, it will guide your LLM along the thought process that it needs to be able to solve the tasks that you've set it, with the tools that you've given it and the skills that you've allowed it, and again the access that you set up on the back end as far as what services it can draw in from. I'll give you some examples of the harnesses that are out there. I mean, the big ones are Claude Code itself has its own harness that it can use. These that you can plug, but again, the question you have to ask is how much hardware do you have? How many resources do you have? Because if you were to put the most extravagant harness onto the most minimal model, for example, it wouldn't know what to do with all of these tools. Realistically, a small, say, 9 to 30 billion parameter model, something that you're likely to be running on home user hardware, might only actually be able to keep track of, say, 5 tools in itself and a handful of skills. Add to that the context and any files or repositories you want to have it look at,
and plus the speed of processing as well. As you mentioned, it can be quite slow.
It can be quite slow, which is where the hurdle really lies, is the speed of it. As I mentioned before, we can run these huge frontier models, trillions of parameters on local hardware. If you've got the hard disk space,
how much would
then
you
need? Can run. Well, I mean, to give you an example, I think Kimi 3 at the minute is that 1.8 billion? Sorry, 1.8 trillion or 2.4 trillion parameters. That's which, in size-wise, we're talking terabytes of space essentially to store it on. Now, to see the speed from that, you'd need to run that on your VRAM, and you need to have essentially.
That's the next question. How much VRAM would you need for that? So, yeah, okay. So if you're taking Kimi 3, which is at the time of recording, like the big Chinese open source model that's there to compete with Fable and the other leading foundational models. So it's massive, but it is possible to take that and install it on your own hardware. But you would need a terabyte or more of hard disk space to download and run the model, but then you'd also need a certain amount of VRAM to be able to process it as well, wouldn't you? VRAM is in your graphics card's RAM. Any idea how much you might need for it, for that kind of model?
Yes. Yeah. The question is how quickly do you want it to respond? If you wanted it to respond instantly, then you'd need as much VRAM as the size of the model to realistically be able to get a quick, accurate response. However, if you were willing to wait and say a token every 10 seconds was acceptable to you, which, in a natural back and forth session is absolutely not acceptable. But let's say you wanted it to analyze some private information overnight, and to create you a summary, perhaps that's an acceptable wait over that time to guarantee the security or that data isn't going to leave your network.
Maybe you want it to process your accounts information, and you don't want to put your bank account details and stuff into a cloud model provider, so you're going to run it locally, but you want a really good model to be able to do a really good job using. Well, let's say we're using Kimi here, and we're okay to leave it for a couple of days and come back and chug through it. But what you would actually want to do is find maybe a maths model or something that's a smaller model that's been developed specifically for accounting, and that would be the model that you would choose in that particular use case.
Yes, and that's where the difficulty lies. Is where how do you begin to orchestrate these models, and how do you begin to decide which ones for which role? Which is easy to do if it's a small task, if it's a narrow flow, if it's something that's quite obvious and repetitive, that's done continuously, then that's easy to address. That's easy to train a model on things like that. It's the real question comes down to is the convenience of just using a subscription model. Sorry, is the sorry, just bear with me. My cat is just
once in on the video. It comes down to the convenience of using a cloud model where you get the immediate back and forth, and you don't need to set all of this up. But the problem is you send in your account's information over the internet into the ether to somebody else's server. It can be hacked. You don't have complete data sovereignty of that information. Risky to do.
That's the truth. Once it leaves your network, it's down to trust. It's trust in the vendor that they're secure, that the line's secure, that once it has left your control, that it is going to be looked after. But why take the risk unnecessarily if it is possible to run it at home, and it's easy enough to run it at home with a local first consideration? Then why? Is the convenience? Is it really down to convenience at that point, or just that you didn't know it was an option to not?
I think it's probably that for most people. Most people don't even realise that there's an option there to go and download a language model that they can run on their own system and set it up. And it's actually not as difficult as you'd think, but it certainly isn't as easy as just paying for a Claude or a ChatGPT subscription and sending it to them, and that for the majority of people will always be the way that they do it. But then you've got to have a lot of trust in. You either don't do the task at all, or you've got to really trust them with that data that you've sent across. If you were to build something like that yourself, then would you go say you'd want to get a model that's probably something that's maybe specially trained on UK accounts information. I don't know if a model like that exists, but the place to go would be Hugging Face to try and see if there's anything even remotely close.
Yes, well, it's a case of sort of working your way back from the problem itself to the solution. What is it that you're trying to achieve? What sort of data sets are you trying to work with? Sometimes it's a case of just normalizing that data. There are models out there that are specifically trained on things like PDFs or PDF views. So if for some reason that information, for example, was just coming through on PDF in various formats with an unknown layout, then there are models that are trained on specifically reading that and drawing the data from those PDFs to be displayed however or summarized however you wanted them. The question is the information needed to be secured? Am I okay with handing that over? Is it really a problem? Because the truth is that setting up a local model and setting up it is easy to set it up, but it is very difficult to get it to work well. In some regards, that takes training, that takes time, it takes consideration, and that takes money. To work those things out. At the moment, there aren't here's the answer. This is how it's done. This is how we do it. This is your solution. There are offerings. I mean, we spoke about the harnesses themselves, and we've spoken about how we might secure that data once, or how we might secure the LLM's access to that data through things like vaults that you could give it issue a certificate from a time-based or task-based certificate.
What was your recommendation for a vault system? I remember you mentioning.
Oh, I mean, there are lots of offerings. The one I use is Beovault. It's open source and allows a lot of the things that I just mentioned as far as securing your API secrets, passwords, whatever it might be that you just want to create a reference for rather than use the actual thing itself. Save you rotating keys every time you accidentally hand it over to your LLM to perform an action. And again, it's a case of, we hand over access to our emails, we hand over access to our calendars and everything else, and you've got to ask, it's permanently got that access. If you were to leave that session open, for example, then at any point those services could be accessed by the LLM using things like vaults, like Beovault and say any Rust-based offerings that are of a similar ilk, basically allow you to say, right, well, yeah, you can have access to that. Here's a reference to it. And when, let's say I have my emails checked and summarized at 10 o'clock in the morning, or at a set time, or when I'm at the computer, say, I can set that certificate to only be valid during a set time, or I can set that certificate to only be valid when I'm at my console, for example. The vault itself will be locked until I open it with my USB key when I'm sat at my computer and I'm actually doing the work. So again, it's a case of thinking about, once you've given it access, how do you manage that? Should it always have access to my emails? Should it always have access to my calendar, or should it just be when I'm interacting with it?
Yeah, it's a fantastic point, especially if you're setting up scheduled or triggered automations where it doesn't need access constantly. It just needs access at the point of needing it or a particular time of day. So instead of giving it the actual API key, you run it through Vault, which can enable and disable the API at those set times, so it only has the access at its set times. Have I got that right?
Exactly. Yes. Yeah. It's essentially issuing a certificate that can be time based. It can be based on many different triggers of what that might be. It could be triggered. It could be issued the certificate on when the action itself is triggered, for example, so that it's not going to be open and accessible whenever it needs it. And the same goes for even for using your subscription LLMs. Yes, we create env files and we create references for them, but again, it doesn't really close the attack vector that's made available. Say, if somebody was to gain access to your system or to your network, that doesn't stop them at that point. It's if they were to gate. I think I think one of the main concerns really is when you start integrating this with your life and giving it access to all of these services, all of these private info sources, is a case of, okay, well, great, I've got access to my data. It's managed. It's being sorted for me. This is very, very productive. And then you might open up a means of communication as far as, well, great, it's got my email. I might now talk to it through Telegram or through WhatsApp and create a means of communication that way. So it's what they call the security trifecta of you now have an LLM with security clearance that can get to the sensitive data that isn't managed. You've then got a means to communicate with that from the outside as far as an email, which it's going to read. And then it's got, on top of that, you might have given it the harness with a bunch of tools and a bunch of skills that it can use. You've got that, and at that point,
and this is the idea of prompt injection, where malicious actors can send an email with a prompt asking the LLM to do something like access whatever you've given it access to. So go into my Google Drive and try and find a file that's called passwords or something like that. So you send an email to that person. The 9 o'clock, 10 o'clock in your case, email run goes off. Mine's at 9. And then it sees the email. I mean, they are quite good at determining between what an actual instruction or a prompt is versus just reading an email these days. But there's always the chance that it comes across some text in an email that makes it prompt to do something, and it's got the access and the skill to go into your Google Drive to find something and then send an email back to the person that it emailed you with the information. And that's, I believe that's how like malicious actors and prompt injections can work. And you've set up that environment for it to be able to do that because you've given it the access to your emails, permanent access. You've given it access to your hard drive or your Google Drive, and you've given it the ability to not just read. You might have given it the ability not just to read emails, but to send emails as well. This is why they usually have a human in the loop where it asks you to confirm the email before sending. But if you've given it full access to send emails, then that's a possibility that can happen.
Absolutely, and that's why you've got to consider how much scope or how much free rein would I like to give the LLM. How much does it realistically need to achieve the tasks that I want from it? And do I need to leave that door open? The questions you need to be asking. And it's really not difficult to take that control back. As I say, through the use of vaults and through the use of the Docker containers or containerizing, or even just having the LLM specifically on a machine itself, on its own machine that is not part of say my work environment or my personal environment. If you don't want to give it access, you can isolate it on a system itself, or in the same respect to a virtual container.
I actually bought a cheap gaming device, and it's the reason being is because it's a Windows handheld gaming thing, but it's got low wattage, so it doesn't cost much to keep plugged in, and it's easy to just wipe and reset. And it's a fresh install of Windows, and because it's a gaming device, it has a lot of RAM, so it allows me to run local models and make use of a fair bit of RAM on the system. It cost me like 260 quid off eBay, and it's it's just something that I play with to put some local models on. It's got a decent amount of RAM. I can keep it plugged in and turned on. It's only using 15 watts, so I thought that was a pretty cool little way to tinker. And if anything goes wrong with it, I just reset it to factory settings, and I'm right back to a fresh install of Windows.
Yes, that's it. And we were saying you'd be surprised what kind of hardware you can run these models on. We've seen them running on mobile phones. We've seen them running on low-end PCs. And again, it really comes, as we said before, it comes down to what's an acceptable level of speed or response time from them. And that's where the orchestration comes in. Sometimes all you need is a simple tool call or a simple. Let's take Home Assistant for example, which is one I mentioned before, which is a very narrow scope of the tools that it can call, and a very repetitive set of commands that within a narrow field of my home's automation.
I'm glad you brought that up, because I think we should be talking for a while, so let's wrap up. But I really wanted to touch on this at the end to wrap up, because I really want you to explain a little bit more about your home automation system that you've set up.
So again, that brings in it's a bit of smoke and mirrors. So if you take the resource restrictions of I can't run a large model quickly, it's going to be responding at a very, very painfully slow rate. But what I can do is run, say, a small model that can know a very narrow trail of thought, a very narrow scope of tasks, a very narrow set of tool sets that it can call. That will work very well in your initial response, and then you can do other things that again, if it's a repetitive zone, you've got things like deterministic responses, for example. If it's a question,
so I lost you there, unfortunately.
Sorry.
But I think that's just because I was recording on my school group and we probably went over time. So we just wanted to wrap up as well. So I just wanted you to explain a little bit more about the system that you've got. As far as I understand it, you have a local model running that can take in voice commands, runs through a small language model that's specific for Internet of Things home devices, finds a particular command like turn the lights on, and then it can go and communicate with your Nexus Hub or whatever you've got. But the benefit of this is none of it actually leaves your home network. It's all running on your own system, your own computer that's in the living room, your own mobile phone. So have I got that right?
Yes, absolutely. And there's a huge community of home assistant enthusiasts, shall we say, that are pooling their ideas as far as how we can apply this quickly, cheaply, and easily in our home, and take ownership of our data in that respect. We mentioned, it constantly listening to us, your video cameras, your video feed, your facial recognition, all of that can be run at home, absolutely, on running the smallest of models on some very, very modest hardware. There really isn't a huge need to send that into the cloud. And again, providers like Alexa and such, they started off with this local first. The original Alexas processed all of the speech to text and the listening, and all that was done locally, and they quietly pulled that, and now it's all done within the cloud. All of your data is being sent off to be processed somewhere, and then the actions brought back to you. There really isn't any need to send that data anywhere beyond your network, or anywhere beyond the network within the Internet of Things devices. Mine certainly don't have access to the internet, and they don't need it.
How does it work then? How have you set it up?
It's very straightforward. The framework again is there. Home Assistant is an app and a community that you can install on something as simple as a mobile phone or a micro PC, an old laptop, whatever it might be. Add your text-to-speech model, your Whisper model that you mentioned. Again, that's usually, under a gigabyte. 100 meg, 500 meg, essentially for what can then run. Most consumer graphics cards or consumer units have at least sort of 2 to 8 gigabytes of VRAM, and that's plenty enough to run anything like that, as far as a small inference model with a modest tool set and skill and knowledge base as far as your preferences. Add to that some extra layers. You could you could add the harness, as we spoke before, to give it the skills and give it the memory and give it actionable tasks, as far as, setting your schedule for your lights, setting the schedule for whatever time you'd want your RoboVacs running, whatever it might be.
Yeah.
But there's no need to send that off into the cloud to have that conversation out loud with anybody else listening, or even just having the ability to listen in is unnecessary. Especially when, as we said, we can run these models on a mobile phone, running it on a modest device with a harness. And in fact, I didn't really touch on a lot of the personal harnesses, the ones that are more geared towards the smaller models. About the larger ones like Claude Code itself, or as a harness. But there are other ones that there are Hermes, there's OpenClaw, there's IronClaw, depending on which side of the fence you sit, as whether security is more of a concern, whether usability, whether there are a large developing user base or developer bases, or an active developer base is more important to you. But again, it's a case of securing that data that you really don't need to necessarily share. We don't need to. It doesn't ever need to leave your network. So why should you? Other than convenience, which is a big argument. It really is, when you can just pay for a model and have it do all of these things for you without really having to do any work at all is beneficial, but it might just be costing you more than just your subscription to do it.
That's a good point. You're offering the customer, if it's free or subsidized, you're the product, as they say. Yeah,
exactly. And if you're not paying for those assurances, you're not paying for the secure API use or whatever it might be, then you very much are the product. The use cases for local models is getting bigger every day. It really is. And as I say, if it's a narrow task, something as far as summarizing your emails, or summarizing any kind of data set, or normalizing that data set, these small models can compete, go toe for toe with the larger models, and you don't have to hand the data over in doing it. It stays on your network, and that's peace of mind in itself, as far as, well, if the model can't, for example, start using the tools that the subscription models can, or have access to all the private data. We spoke before about giving it access to the private data, and then giving it access to the outside world beyond your network, and then giving it access to your email. That opens up doors. That opens up doors to attack vectors. That really does leave you susceptible to, when the grenade does go off, how much damage is going to happen.
Keeping that blast radius contained.
Exactly. It's about limiting that blast radius. If they're on your network, how far can they go? If they get access to your login for your API subscription, have you left the chat open, a coding chat open? Yes, the door is wide open, essentially.
I think, George, that's a really good point to end on. I don't want to go too much over time on this podcast, but I mean, obviously we could talk for hours and hours and hours on this, because it's a really fascinating subject, and you've really experimented a lot, and I really like what you've done with your home network, and looking and trialing out these different models. And you've got the right mindset. You're very much thinking about data sovereignty and data security, and I think that's something that's going to come up a lot more, if it's not already, but a lot more with businesses in the future, where they're thinking, well, how do we protect our IP? How do we protect our information? And we don't want to get slapped with fines, with regulations from the UAI Safety Act or GDPR and things like that. So I know businesses are already thinking about it, but Yeah, it's a big debate, and I don't think a lot of them realise just how easy it is to take back control and run local models on their own network, whether that be their own home private network or inside of a company.
Absolutely, it's a case of, for businesses themselves, there could be a return on investment case there. The API costs for using the
Yes.
frontier subscription models are exceptionally high, and that can certainly add up when you start plugging more and more services into it and asking more and more of it.
With more and more staff members, exactly. And
Exactly.
if
At
any
some point,
business does want any consultation around this kind of stuff, you'd be the ideal person to come to and ask if you if you were willing to have these conversations.
I'm always happy to have these conversations with anybody that's willing to be open to the discussion of securing your data and securing your LLM more to the point, of what it has access to and the risks that you open yourself up to in giving it more access and giving it all the convenience of its applicability. They really have enabled us to really become very, very productive. But you do have to stop at certain points and just ask, do we need to hand this over? Should I be handing this over? Can I manage this in another way? Because once that information has left your network, there is no way to manage it personally or as a business point of view. From that point, you can secure yourself with any terms and conditions or promises, but the reality is it's in their hands rather than yours, and sometimes you have to ask yourself, should I even be making that available or exposing myself to those risks unnecessarily when it could be
Absolutely.
It could be run locally without too much effort.
Absolutely. Okay. Thanks for coming on, George. I think it's been really fascinating, and it's such a hot topic at the moment. So I really appreciate your wisdom on this, and thanks for coming on the show and spending the time with me.
Always happy to talk, Mike, and as I say, it's an ever-changing field. It's one where the answers of today aren't the answers tomorrow, and the same for the questions that we ask. It's how we said it's ever evolving, and we just need to realize what's available to us rather than just going with what's most convenient. I think sometimes it might be productive, but it might also not be secure. Yeah. I think is the takeaway. Awesome. But thanks again, Mike. It's great to see you.
Join the AI for Business School community, where we meet every week and have showcases of how developers are implementing AI solutions for businesses, helping you to discover new ways to automate and innovate in your business processes. Head over to learnmanagementonline.com to find out more.